Hello, boys and girls. Welcome back to another edition of Think Different Television. Okay, so we are going to look at slopes again. Why are we looking at slopes? Why are we doing Algebra 1? Well, parallel and perpendicular lines. We talked about those before, and now they're coming up on a coordinate plane, and so therefore we have to talk about them in geometry. All right, so if you identify the slopes of parallel lines and perpendicular lines, you have to know which is which. So here are the two things I want you to write down. And I wrote them down right here in my notes. So copy this down. Here's your title, Parallel and Perpendicular Lines of Slopes. So two lines have the same slope if and only if they are parallel. So parallel lines have the same slope. So if one slope is a third, up 1, right 3, the other slope, slope 2, m stands for slope, remember, equals 1/3. So the slopes are the same. One slope is 2. The other slope is 2. If one slope is -1/2, the other slope is -1/2, etc. Next thing, two lines are perpendicular. What's perpendicular mean again? Oh yeah, forms a right angle. Actually, it forms 4 right angles. Add to your notes. So it's perpendicular. There's two lines intersect that form a right angle. But also, this is a right angle, this is a right angle, this is a right angle, so it's 4 right angles. But you only put that one right there. The other one are just implied. The other 3 right angles are just implied. So two lines are perpendicular if and only if they have negative reciprocal slopes. Or you could say opposite reciprocal. People like to say that also, opposite reciprocals. Opposite means that you change the sign, so positive to negative, negative to positive. Reciprocal means that the fraction is flipped, essentially. So let's look at an example. So if the slope is 1/2, so the opposite of positive would be negative, and this is the perpendicular slope. Remember, upside down t means perpendicular, and so the reciprocal of 1/2 is 2/1. So it went from positive to negative, went from 1/2 to 2/1. So if the slope is -2/3, if it's negative, the opposite of negative is positive. So here's the parallel slope, sorry, perpendicular slope. And then 2/3 changes to 3/2. If the slope is 5, you put the 5/1, it goes from positive to negative, and 5/1 to 1/5. So those are the perpendicular slopes. Try this one. If the slope is -5/3, what's the perpendicular slope? Yeah, 3/5. Correct. Cool. Let's try an example. All right, so we got this example. Let's check it out in our worksheet. So find the slope of a line parallel to the line containing A, -3,4, and B, 2,5. So copy this part down right here, this bold part. We're going to try and get this answer. So I want a slope of a line that is parallel. Parallel, I'm looking at my notes. Parallel is same slope. So I got it from right here, same slope. So I got to find the slope first, right? So A is -3,4. Copy down the chart with me. And B is 2,5. The change in Y is from 4 to 5, you're going up 1. From negative to positive, you're going up. You're going up 3 to 0, and then 2 more, so that's 5. So your slope is change in Y over change in X, which is 1/5. Cool. So that means any perpendicular slope, any parallel slope would have the same slope, 1/5. Cool. Why is that? Let's see. Draw a picture. It's just numbers unless it's a picture, right? So A is -3,4. 1, 2, 3, 1, 2, 3, 4. Here's A, -3,4, and B is 2,5. 1, 2, 1, 2, 3, 4, 5. Bam. And so B is 2,5. So this is the line we're talking about right here. And there is an infinite amount of parallel lines. So that's a parallel line, that's a parallel line, that's a parallel line, that's a parallel line. So you can just keep drawing them forever. So if you start here at 0, 2, for example, a parallel line would be, parallel slope would be 1, 5. So up 1, right 5. 1, 2, 3, 4, 5. So if I connect these, oh, look, it's parallel. Never touching. There you go. Same slope. So up 1, 1, 2, 3, 4. Oh, I went 1. Didn't look right. I miscounted. 1, 2, 3, 4, 5. Yeah. Got a model excellence. There you go. So these two lines are parallel. Make the little... No, I could have started here at the origin because right here it doesn't matter. So there's an infinite amount of parallel lines. So any parallel line to A and B would have a 1/5 slope. Cool. Let's try another one. Next. All right, we have find the example 2. Find the slope of a line perpendicular to PQ. P is -2, -4, and Q is 4, 3. Okay, perpendicular, that's in my head right now. Perpendicular is opposite reciprocal slope. Opposite reciprocal slope. So first I gotta find the slope. First step, find the slope. Get your chart down, doesn't matter what is first. So -2, -4 for P, and Q is 4, 3. Write this down with me. Change in Y. Negative to positive, you're going up how much? 7, yeah. And then the X, you go from -2 to 4. You're going negative to positive, so you're going up how many? Yeah, 6. So your slope is change in Y over change in X. Cool. So if we're drawing a picture, whoop. So -2, 1, 2, 1, 2, 3, 4. So -2, -4, this would be P. Got it? And Q is 4, 3. 1, 2, 3, 4. 1, 2, 3. So this is PQ. It looks like this. It's got a positive slope of 7 over 6, right? Up 7. 1, 2, 3, 4, 5, 6, 7. And right 6. 1, 2, 3, 4, 5, 6. Cool. Now perpendicular to that, like something like this, right? Oh, sorry, you can't see that. Something like this that forms a right angle. So it could be this line, it could be this line, forms a right angle, could be this line, forms a right angle, etc. So it could be, there's an infinite amount of perpendicular lines to this, but the one defining factor, the slope, has to be the opposite reciprocal of this. So that would be, if it's positive, I'm going to make it negative. That's the opposite. And then I do the reciprocal, which is 6 over 7. So if I pick a point, let's pick the origin. That's easy, right? So the slope is -6. 1, 2, 3, 4, 5, 6. And then right 7. 1, 2, 3, 4, 5, 6, 7. Like that. So if I connect these dots, whoop, that's a perpendicular line. There's a right angle right there. I could have picked this point, any point, but I just picked the origin because it was easy, and that's a demonstration of what it looks like. Okay? Now, determine whether MN and RS are parallel, perpendicular, or neither. So we're going to get into these problems right here. So copy these down. 1, 2, 3, 4, 5, 6. So we're going to go 1, 2, 3 first. So I got two lines, MN and RS. Are they parallel, perpendicular, or neither? Let's see. Okie dokie. So MN, so this line here and this line here. So it's talking about 2. So I think I'll have to find the slope here and the slope here and then compare. So do as I do. 0, 3 for M, and N is 2, 4. What's the slope? Figure it out. 1 over 2. So the slope is 1/2 of MN. So this is MN. Line MN. All right, RS now. X, Y, 2, 1, and 8, 4. What's this slope? Let's see. That's going to be 3 over 2 to 8 is 6. You can just subtract the bottom from the top. You realize that? 8 minus 2 is 6. 4 minus 1 is 3. So your slope is 3 over 6. Can I simplify this? Yeah. That's the same as 1/2. So the slope of, this is RS. The slope of RS is 1/2, and the slope is MN is 1/2. So if they have the same slope, are they parallel, perpendicular, or neither? They're going to be parallel. Yeah, why? Because they have the same slope. Both lines have the same slope. Cool. Let's do another one. So same setup. So I gotta find the slope of MN and RS and then see whether they're parallel, perpendicular, or neither. Let's do it. Negative 1, 3, 0, 5 for MN, line MN. Find the slope. That's going to be 2. And negative to 0, that's up 1. So the slope is 2 over 1, or 2, you could say. All right, RS. 2, 1, and 6, and negative 1. All right, so this 1 to negative 1 is down 2. And then 2 to 6, that's up 4. Okay, slope is change in y over change in x. Negative 2 over 4. Simplify that. That's going to be negative 1/2. Okay, so the slope is 2 over 1 and negative 1/2. That's opposite, right? Positive to negative. Is it the reciprocal? 2 over 1 to 1 over 2. Yeah. Opposite reciprocal slope. So this is ding, 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 perpendicular. Perpendicular. There you go. All right, last one. Doing good. MN. Whoop. Number 3. You should get this from your notes. Of course, pause the video and do it again if you need, or look at the PDF that's attached. So line MN, what's the slope? 1/5. 1 over 5. Okay, RS, do the same thing. 3, 1, negative 2, 2. So that's going to be 1 and whoop, 3 to negative 2, that's negative 5, because you go from positive to negative, you're going down. So the slope is 1 over negative 5. All right, now let's take stock of what we got. 1/5 and negative 1/5. So it's opposite, right? It's not the same, so it's not parallel. I can eliminate that. It's not parallel. But we have opposite, positive, and negative. But is it the reciprocal? No. No. So it's not parallel and it's not perpendicular. So this is neither. Got it. All right, next. Good job so far. I want you to do 4, 5, and 6 on your own. 4, 5, and 6. Put your answers in the play posit. All right, great job, everybody.